couple of things that we're going to use a battery for. Batteries are necessary in our equipment for basically three main things. First one, provides current during starting ignition. Obviously, if I don't want to have to go out there and pull a rope, I'm going to need something to turn that starter over. So for starting, and if you have anything but a magneto system, then you need something to energize the ignition circuit to start it up. Second one provides current along with the alternator to operate lights and radio and stuff during peak loads. If you're operating your vehicle and you got a foggy windshield, you got your radio on all the way, you've got your defrost on, you've got your lights on because it's early morning, your engine's cold, you've been cranking on it because you don't have a very good battery, you know, you're putting a lot of demand on your alternator. Alternator may not be able to keep up, and so your battery basically supplements for it. When you turn your blinkers on, your alternator has to try to compensate, and your blinkers come on, they need electricity, they go off. So instead of your alternator constantly jumping up and going down and jumping up and going down in voltage, basically what happens is my battery acts as a shock absorber and kind of smooths it out so your alternator can actually charge more evenly. So it acts as a reservoir and a stabilizer, as a shock absorber for the system. Construction, basically made out of some sort of plastic or rubber. There's a lot of differences in the particular type of material they have. There's glass up there, but you'll probably never see a glass one. Glass ones are only used in stationary applications. So the difference in this plastic and rubber comes down to the manufacturer, who you buy your batteries from. The better quality batteries have a little bit better construction, and so they actually absorb vibration and stuff better. Inside your battery, when you look at the inside of this battery and the cutaway, within the battery there's going to be a series of plates. There's going to be negative plates and positive plates. The negative plates are lead sponge. The positive plates are lead peroxide. In between each one of those plates is a separator plate, and that's just like an insulator. It keeps the two of them from touching each other. How does the battery work? How do these plates that are sitting in this electrolyte solution actually function? We're going to look at what actually takes place in the battery. And is this important? I mean, knowing exactly how it chemically reacts and all that, is that important? I keep turning it the wrong way. I don't expect you to know exactly all this chemical reaction, but there's some terminology that you're going to hear when they start talking about batteries and problems and issues with batteries, and that's why I'm going to cover this. So when you look at this, during the discharge, you got a battery, and you're cranking on your starter. During the discharge process, every one of those cells, and in this particular battery there's 6 cells, each cell has a minimum of 1 positive plate and 1 negative plate. Surrounding that is going to be a solution of an electrolyte solution. This is what the electrolyte solution looks like. You've got a liquid. The liquid is H2SO4. That's sulfuric acid and hydrogen. The 2 plates, the positive plate is lead sponge. That's lead this is lead peroxide and this is lead sponge. When you discharge a battery and you're cranking on the starter, what's going to happen is this electrolyte solution breaks down. It chemically reacts with the plates. The SO4, which is the sulfuric acid, will attach itself to the lead. This O2 oxygen molecule breaks free from this bond and attaches itself to the hydrogen molecule. When it does that, what you're left with is a solution of H2O, which is water, and over here on this plate, this PbSO4 becomes lead sulfate. So if you're working around batteries and somebody says, well, I think your battery is sulfated, the terminology where they get that from is from right here. This PbSO4, lead sulfate, it's become sulfated. What's happened is the sulfur, or the sulfuric acid in the solution, has attached itself to the lead plate. It forms a really hard, crusty surface, and when that takes place, there's no chemical reaction between the electrolyte and the plates. And when that doesn't happen, if there's no chemical reaction, your battery is deemed dead. It's discharged, it doesn't work. And so that's where that terminology sulfated comes from. The other thing that's important is this solution that's in between is now water. So if you go out there in the winter, you're late for school, you get out and you try to start your engine, you're cranking, crank. Dang, battery's dead, I'm late. You jump out of your car, you jump in your buddy's car, you go to work, or you go to school. A couple of days later, you get time to get in there, you try to charge your battery and it doesn't work. And you do all this testing and find out, well, my battery's bad. Well, what can happen is if you leave it discharged and it just has water in there and it's freezing out, the water freezes, it expands, water freezes, expands, it pushes on these two plates, and by looking at this battery, you can see there's not a lot of space in there. When it freezes, expands, it breaks the plates apart. The plates touch each other, and as soon as this plate touches this plate, it shorts out internally, and your battery is bad. You have to replace it. You don't have a choice. And so it's very important that you never allow a battery that's discharged to sit in a cold environment because it will freeze. It freezes because the solution that's in here is actually attached to the plate.
So that, you do a load test on your battery? Is that